Welcome to a new section of this course, Simulation of Human Thinking, Artificial Neural Networks. This section will show you how to use neural networks to fit data, to classify patterns, and for clustering. You'll learn pre-processing, post-processing, and network visualization for improving training efficiency and assessing network performance. We'll also analyze how to properly divide the data before submitting it to the network. Now we move on to the first video of this section, where we will get started with neural networks. In this video, we will understand what neural networks are and how the architecture of neural networks is. ANNs are information processing systems that try to simulate within a computer system the functioning of biological nervous systems that are made up of large numbers of nerve cells or neurons connected to each other in a complex network. Each neuron is connected, on an average, with tens of thousands of other neurons, with hundreds of billions of connections. Intelligent behavior emerges from the many interactions between these interconnected units. Here's a diagram illustrating this concept. Some of these units receive information from the environment, others emit responses to the environment, and others, if they are there, communicate only with the units within the network. These three are defined as input units, output units, and hidden units, respectively. Each unit performs a very simple operation that involves activating if the total amount of signal received exceeds an activation threshold. If a unit becomes active, it emits a signal that is transmitted along the communication channels to other units to which it is connected. Each connection point acts as a filter that transforms the received message into an excited or inhibitory signal, increasing or decreasing at the same time the intensity according to its individual characteristics. The input-output link is not programmed, but is simply obtained from a learning process based on empirical data that may be of these kinds: supervised, unsupervised, and reinforcement learning. Neural networks work in parallel and are therefore able to deal with lots of data at the same time, as opposed to serial computers in which each one is processed individually and in succession. Here's a figure giving a comparison between serial processing and parallel processing. Models produced by neural networks, though very efficient, cannot be explained in human symbolic language. The results must be accepted as they are, from which the definition of neural networks as black box, as you can see in this figure. As with any modeling algorithm, neural networks are also efficient only if predictive variables are carefully chosen. They require a system training phase that sets the weights of individual neurons, and this phase can take a long time if the number of records and variables analyzed is very large. There are no theorems or models that allow us to define the network, so the success of a network depends greatly on the creator's experience. Neural networks are usually used in situations where data may be partially incorrect, or where no analytic models are available to deal with the problem. Their typical use is in OCR software, facial recognition systems, and more generally in systems dealing with handling data that is subject to error or noise. They are also one of the most used tools in data mining analysis. That's all for this video.